Happy New Year, everyone. It's almost the new year. It's December 30 and it's almost 2021. So now Explore Math has started a new series in which we will post 1 to 2 videos every week, no matter what, for about 1 to 2 years, which will cover one concept in each video with three example problems and one very basic problem. And the 3 example problems will be one at the AMC 8 level, the next one will be at the AMC 10/12 level, and the last one will be at the AIME level. Even if you're at the AMC 8 level right now, we will make the explanations so that even the AMC 8 learners can understand the AIME problems, the problems that we will give. So let's get started with our first problem. In rectangle ABCD, AD is 1, and P is on AB, and DB and DP trisect angle ADC. Now it's asking us for the perimeter of BDP, and for those who don't know, this is just a problem from the AMC 10, and this is our example problem. So whenever you see a geometry problem, draw it out. Basically, we have the diagram here, but let's start labeling it, and maybe we might see the answer. So we know AD is 1. It says these two lines DB and DP trisect ADC, and this is pretty much the most important part of the problem. If an angle is trisected, that means it's divided in half, and we know angle D is just 90 degrees because it's one of the angles of the rectangle, and a rectangle has all 4 angles that are 90. So that means each of these angles, ADP, PDB, and BDC, they're all 90 divided by 3, which is simply just 30 degrees. So they're all 30 degrees. Now, it's asking us to find the perimeter of triangle BDP. This problem might look hard at first, but I'm going to show you another slide, and I think that should clear it up. So what do we know? We know that angle A is just 90 degrees because angle A is also an angle of the rectangle, and angle APD is just 60 degrees because we know a triangle sums up to 180, 90 plus 30 is 120, 180 minus 120 is 60. What else do we know? We know that angle DPB is 120 degrees because 180 minus 60 is 120. What else do we know? We know that angle PBD is 30 degrees because 120 plus 30 is 150, and you still need 30 more to make 180. So this is also 30 degrees. But I still don't see what's happening. I mean, it can be confusing at first. But now let's clear it up. For any 30, 60, 90 triangle, the side opposite to 30, pretend the side opposite to 30 is x. Well, that means the side opposite to 90 is 2x, and the side opposite to 60 is x times the square root of 3, no matter what. Now, if you don't believe this ratio, this pattern, then I'm gonna prove it to you guys very quickly. So pretend I have an equilateral triangle, and let me label it A, B, C. Now let's pretend the triangle has side lengths which are 2x. And if it's equilateral, that means all the angles and all the sides are the same. So we can start labeling. This is 2x, and this is 2x. We know this is 60 because it's an equilateral triangle. This is also 60. We know angle A is also 60, but now I'm going to draw a line that cuts angle A in half and divides segment CB in half by a perpendicular line. Now if I draw a perpendicular line, we know this is going to be 90, and this is also going to be 90. And in this case, if I divide CB in half, that means it's no longer 2x. They're both x each, which adds up to 2x, but the individual lengths are x. So pretend I'm gonna add more labels here. Pretend this is point D. That means this is all x, this segment is x, and this segment is x. We know angle CAD is 30 degrees. And now we want to find the length of AD. Now you can just use the Pythagorean theorem because ACD is a right triangle, and if you do so, you get 2x squared equals to x squared plus AD squared. If someone does not know the Pythagorean theorem, please put it in the comment section below. I'll try to make a video on it as soon as possible if I see people that don't know it. So if you solve this out, 2x squared, so it's just 2x times 2x, which is 4x squared, and you subtract x squared from it, and you get 3x squared. 3x squared equals to AD squared. And then to for such an equation, all you have to do is square root both sides. And if you square root both sides, you just get AD equals to 3x squared, which is x squared. If you square root x squared, you just get x times the square root of 3. That means the height is x times the square root of 3. And if you look at triangle ACD, it's just the exact same thing as this figure on the left, this one. The side opposite to 90, if that's 2x, then the side opposite to 30 is half of that. It's the exact same ratios. And now let's try to solve the other problem, since we made a 30, 60, 90 triangle. Now in this problem, we do see that the side opposite to 60 is 1. So let's pretend the side opposite to 30 is just x, and the side opposite to 90, we know it's double, so it's 2x. And the side opposite to 60 is always x times the square root of 3, and in which case x is the side opposite to 30, which is AP. So x times the square root of 3 is AD, but we also know that's equivalent to 1. And now we can find the side lengths of the other sides of the triangle. You divide both sides by the square root of 3, and you get x equals to 1 over square root of 3. And now you multiply both sides by the square root of 3. It's called rationalizing it, and you get square root of 3 over, if you multiply two square roots, it just cancels out if the term under is the same. So square root of 3 times the square root of 3 is just 3. So that is the side, that is what x is equivalent to. And now if x is equivalent to that, we know that dp is just double that. And we know dpb is an isosceles triangle. That means two of the sides are the same, which means pb is the same as 2x. So now, to find 2x, this is x. So we're going to multiply this by 2. 2 times the square root of 3 over 3. Now that's dp. You multiply that by 2 to get dp plus pb. And if you multiply it by 2, you get 4 times the square root of 3 over 3. Now all we want to do is find the length of db, which is also the hypotenuse of triangle ADB. And in this case, all you have to do is now use the Pythagorean theorem. AD squared, which is just 1. I'm going to make space now. So AD squared, which is 1, plus CD squared. I erased too much. Wait. Okay. So we know AD squared, which is 1, plus we know x. Oh, sorry, I accidentally erased the value of x accidentally. So we know x is 2 times the square root of 3 over 3. And we know AB is 3x. So we just multiply. X is just square root of 3 over 3. So if AB is 3x, you multiply x by 3. And if you do that, you know that these just cancel out. So x is just square root of 3. And according to the Pythagorean theorem, you square that. 1 plus 3 equals to BD squared. Now you might see what BD is immediately. It's just BD squared equals to 4. And you square root both sides and get BD equals to 2. And that is the final length. So you add this to the other two sides, and this is the answer. So you see that 30, 60, 90 triangles is a very important concept. This problem could be a bit hard to attack, but with 30, 60, 90 triangles, it became very easy. So let's get started with our next problem, which is more at the AMC 8 level. So in rectangle ABCD, we know that angle C is trisected by CF and CE. Now we're going to stop reading immediately, and we see the word trisected. And if an angle is trisected, it is divided into 3 equal parts, which means this is 30. This is 30. And this is 30. Okay, let's read on now. Now we know F is on AD. We have BE equals to 6 and AF, which is equivalent to 2. Now, which of the following is closest to the area of ABCD, of rectangle ABCD? Okay, so we know angle BC is 30. We know angle B is 90 degrees because it's just one of the angles of the rectangle. Through that, we can find out angle E, which is 60. And now we got some 30, 60, 90 triangles here. If the side opposite to 30 is 6, the side opposite to 90 is double of that. It means 6 times 2, 12. And the side opposite to 60 is square root of 3 times that, which means this is 6 times the square root of 3. We found out one of the lengths of this rectangle. Now we need to find out the other one, which is either CD or AB. We know they're both the same. AB looks a bit harder to find because we would have to add EB and AE. And to find AE, the shape CFAE is looks weird to me. I'd rather find CD since it's a triangle there. So let's try. So we know what is CD. We know that's 90. I'm not CD, I mean angle D. We know if this is 30, then this is just 60. Maybe you think we don't know any of the side lengths of triangle CD. CDF. You're completely wrong. Because we know CB is 6 square root of 3 and FA is 2. But if you subtract those, you get DF, which means the side opposite to 30 in triangle DCF is just 6 square root of 3 minus 2. That means the side opposite to 90. We don't need the side opposite to 90. We just want the length of DC, which is the side opposite to 60. And now all we do is multiply the side length of DF by by square root of 3. So you get 6 times the square root of 3 minus 2 times the square root of 3. And now we're going to find the length of DC. And if you multiply this, square root of 3 times square root of 3, square roots cancel out. You get 18 minus 2 times the square root of 3. And that is DC. So now all we do, we got both of the lengths, you multiply them with each other. We know the other one is 6 square root of 3. And if you multiply this, 18 times 6, 108, square root of 3 minus 6 times 2, we know that's 12. Square root of 3 times square root of 3 becomes 3 times 3. And at the end, 12 times 3 is 36. You can simplify this on your own, but this is the answer. 108 times square root of 3 minus 36. You can simplify this if you want to. Now, the next problem. In rectangle ABCD, we have AB, which is 20, and BC, which is 10. Let E be a point on CD, such that CB is 15 degrees. What is AE? Whenever you see a geometry problem and the diagram is not given, your first step should be to draw it. So we know it's a rectangle, so let's draw one. Okay, boom, we have a rectangle there. And now let's label the sides. We know this is A, B, C, and D. And now let's draw out what's given in order. We know AB is 20 and BC is 10. Now E is on CD such that angle CBE is 15 degrees. So I'm just going to plot it out over here. Pretend this is E. Then we know this is 15. We know angle C is 90 because it's just one of the angles of the rectangle. So if this is 90, we can find out BEC, angle BEC, which is just 75. And we want to find out AE, so I'm just going to draw out the segment there. We know ADE, triangle AD is a right triangle. I don't really even see a method here, but when you see triangles or shapes, maybe try to draw more triangles. Maybe sometimes in problems, you won't see 30, 60, 90 triangles. What if you make them inside the problem? Now that's our goal. We want to make 30, 60, 90 triangles now. Now 75. Now 75 is just equals to 60 plus 15. Now to try to solve this problem, you see I divided 75 into two parts of 60 and 15. Now we're going to make a line in triangle BCE that divides it into those two angles, 60 and 15. Let's do that. Okay, basically pretend we got this angle is 60 and this angle is 15. And this angle over here is 30. Now this problem is starting to make a bit more sense because we have 30, 60, 90 triangles. What do we know about these 30, 60, 90 triangles? Pretend the side opposite to 30, let's just say it's x. That means the side opposite to 60 is x times the square root of 3. And we know the side opposite to 90 is just 2x. And this is where we notice that the triangle we made with two 15-degree angles is just an isosceles triangle, which means the other segment here, pretend this is F, is also 2x. And this means 2x plus x times square root of 3 equals to 10. And now we can find x. 2x plus x times the square root of 3 equals to 10. Now we're going to factor x in this. X times 2. plus the square root of 3 equals to 10. Now we divide 2 plus square root of 3 from both sides. And after you divide it from both sides, you get x equals to 10 over 2 plus square root of 3. And now we're going to rationalize it. When you rationalize, you just multiply the term with its conjugate. Basically, pretend it's like it has two terms in it. You just multiply it by the exact same thing, except you reverse the symbols. If you reverse the symbol, you just get 2 minus square root of 3. So we're just going to multiply it by times 2 minus square root of 3 from both sides. And after you do the calculations, you'll get 10 times 2, 20, minus 10 square root of 3 over 2 times 2, 4, minus square root of 3 times square root of 3 is just 1. So we can just leave it as 20 minus 10 times square root of 10 times square root of 3, which is x. And now it's asking us to find AE. So we do know that AD is 10, and we know CD is just 20 because it's equivalent to AB. So, but we want to find AE. We can use the Pythagorean theorem now. AD squared plus DE squared equals to AE squared. And we're going to go with that idea. So let me make some space now. Okay. So to find the length, so now pretend this is just f. So now to find df, all you have to do is subtract cf from it. And from our before calculations, we know the opposite to 30 was just x, and x is 20 minus 10 times 20 minus 10 times square root of 3, and we have cd, which is 20 minus 10 times 20 minus 20 minus 10 square root of 3, and the 20s cancel out, and the negative becomes positive, which leaves 10 square root of 3. And then if now you can use the Pythagorean theorem. You get 10 squared, which is 100, plus 10 times square root of 3. If you square that, you get 300. And if you add this up, you get 400. And you square root that, and you get 20. And AE is just 20. And 20 is our final answer. Now I have a bit homework for you guys. After watching this video, go to the comment section below and try to find out a method. At the end, we found out AD was 10, DF was 10 square root of 3, and AF was 20. AE was 20. And do you notice it's just a it's just a 30, 60, 90 triple. Since the opposite of 30 is 10, the opposite of 90 is double that, and the opposite of 60 is times square root of 3 of that. So I want you to answer in the comment section below why at the end it became a 30, 60, 90 triangle. Now this is our last problem, which is at the AIME level, and it's going to be a bit harder than the other ones, but hopefully we will try to crack it out. So it says, in triangle ABC, we have angles A and B that measure 60 degrees and 45 degrees. Whenever I see triangle or square or any shape in general, and there is no diagram, I first draw it before even reading further. So we know we have a triangle, and pretend this is angle A. We know it is 60 degrees. And we have, pretend I have angle B here, that's 45. So we know B is 45, and this is point C. Now it says the bisector of angle A intersects BC at T. So if angle A is bisected, pretend the bisector means it divides it in half, and this is the segment, and it intersects BC at T. By the way, remember when we saw the term trisect? Trisect meant it divided the angle into 3 equal parts. Bisect is similar, it's just 2 equal parts. And if 60 degrees is divided into 2 equal parts, we know it's just 60 divided by 2, 30. So we know this is 30, and this is 30. What else do we know? And we also know that B is 45. And then it says the area of triangle ABC can be written in the form a plus b times the square root of c, where a, b, and c are positive integers and c is not divisible by the square of any prime. And it's asking us to find the area. It's asking us to find the area and adding up the terms a, b, and c. I don't see a method right now, so let's investigate the problem a bit. We know angle A is 60 and angle B is 45. The sum is 105. We know angle C is just 75. Through this, we know ACT is a right triangle, and one of the angles is 30, one is 75. You add those, subtract it from 180, you find this CTA is also 75. Oh, it's an isosceles triangle, and that means two of the sides are equal, and we know AT is 24. This means AC is 24, and it's one of the important parts of the problem that we found out. Now I'm seeing an angle measure here. Angle A is 60 degrees, and whenever I see something related to 60, I think about 30, 60, 90. And remember, you're not always gonna see 30, 60, 90 triangles drawn for you. Sometimes you have to draw them for yourself and then find the answer. And this is similar here. We're gonna make 30, 60, 90 triangles. So if you see 75 is equivalent to 30 plus 45. So I'm gonna do something similar. I'm gonna make an altitude from C to AB, a perpendicular altitude. So we know this is gonna be 90, and this is also gonna be 90. Pretend this is point E, for example. So what do we know? We know that if one angle is 60, the other is 90. 90 plus 60, 150. You subtract that from 180, and you get 30. So ACE is 30, and we know the entire angle of angle C is 75. So that means ECT is just 45 degrees. And now let's try to solve the problem. Now, if you notice, I hope you notice this, but triangle ACE is 30, 60, 90 triangle, and I think that's where the answer will start to come in. Basically, if the side opposite to 90 is 24, we know the side opposite to 30 was half of the side opposite to 90. That means the side opposite to 30 is 12, and the side opposite to 60, which is the altitude in this case, remember, it's just times square root of 3 of the 30 degree side, which is 12 square root of 3. We found out one part of the problem, the altitude of the triangle, 12 square root of 3. That's the altitude. Now we want to find out the base, which is AB. And in this case, if you notice, angle C is 45, angle B is 45, angle CEB is 90. It's an isosceles right triangle, which means two of the sides are the same. We know that CE, which is the altitude in this case, is 12 square root of 3. That means the side opposite to angle C, which ECB in the 45, 45, 90 triangle, which is EB, is equivalent to CE. That means this EB is 12 square root of 3 also. And now we found out the base and the height. And now we will find out the area of the triangle. We know the base. That's 12 plus 12 square root of 3. We know the height times 12 square root of 3. And the area of a triangle formula is just 1/2 times base times height. So I'm just going to cancel out the 1/2 with the term over here, which makes it 6 square root of 3. And now it's just some multiplication left. 12 times 6, 72. 72 times the square root of 3 plus 12 times 6, 72 times 3 times square root of 3 times square root of 3, which is 3. So you get 72 times 3. 72 times 3, which is just 216. And this is the area of the triangle. So now, before you write this down or pretend you're taking the AIME, remember, it says find A plus B plus C. So all we have to do is add 72, 3, and 216. And when you do that, you get 72 plus 3, 75, plus 216. Adding this, you get 291, which is our final answer. Now I hope this video helped you understand the concept of 30, 60, 90 triangles and how If you don't see 30, 60, 90 triangles, you make 30, 60, 90 triangles. Now use these methods, and don't forget to like, share, and subscribe if you like this and want more videos like this coming up soon on different topics. If you have any questions in general about anything or a math problem, please put in the comment section below, or you need any help, we will reply back. And thank you for watching.